Now in this section, we're going to look at functions. Functions are pivotal to modern software development because with a function, we can organize our code and then refer to a function name anytime that we want to execute that code. So we don't have to paste the code over and over to make it run. So let's take an example. Let's take a very simple function called print menu. With print menu, it might do in our little mock program here, it might do exactly what you think. Maybe we print a menu for the user. Let's see, let's number these 1, 2, 3, and 4. Edit. Delete. And maybe show all. This is what we call a function definition here, or a function header. We define a function with a def keyword, and then this is our function name called print menu. Now, if we run this, what do you think appears in our console? The answer is nothing. Nothing appears because we defined a function, but we never called it. So to call a function, we would type in this, print menu, the name of our function. This is how we reference our function in the code. So if we run this, it shows us our menu. Now this isn't a real program with a real menu, and we don't really have functionality for adding and deleting cars. But it does show you how to declare or define a basic function. Now, just like with if statements and for loops and while loops, the indentions mean something. The indentions mean that everything here goes with the function. So for example, down here, if we just printed, some other command, the print function is pretty easy. Even if we never called the print menu function, if we run this, you'll see that something still prints because it's not a part of the print menu function. And we can just delete this back out here. And let's comment all this out for a moment so we can move on. We can also have a different type of function, a function that understands or has parameters. Like suppose that we had a function maybe called greet. So we make our function called greet, and maybe it takes a first name and a last name. Now in this function called greet, we want to just greet the user. So we might say something like print hi, and I'm going to show you something that maybe you haven't shown you in the video. The book goes over this in an earlier chapter, but we can use the format command in Python to format the display of information. So what we're saying here is hi. This is going to print hi to the screen, and then it's going to print these two brackets. These are placeholders. For first name goes here, and last name goes here. So the sets of brackets are placeholders for first name and last name. And this is done with the format. You can do this other ways, like you've been doing possibly with string concatenation. That's fine. But I thought I would just work this in here because the book has gone over it a few times now, although I haven't picked it up here in the video. And we might say, welcome aboard. I don't know, something like that. Now, if we want to call this function, how would we do it? We would type in greet, you know that, before we called it like that. The reason we called this previous function just with the closed parentheses and nothing inside is because it didn't, this function here, print menu, it didn't have any function parameters. These are called parameters. They can then be referenced inside the function. So what we'll do is we'll pass, it's expecting a string up there, first name and last name. And when we call the function with the first name and the last name, first name becomes right here, and the last name goes right here in this variable, last name. And then we can access those variables inside the function anytime we need them. Well, we need them to be able to print out. So we reference first name, which when we run it like this, it will be set to Josh, and then the last name will be set to Bond. Now, if we run this, it says, "Hi, Josh Bond, welcome aboard." What if we run this again? And we type in someone else's name. And what do you think it's going to print now? The first time it runs, which is the first call up here, it prints Josh Bond. The second time it prints Stephen Wakefield. And so you can see that a function can be called to save duplicate code. We didn't have to print this twice manually. And a loop wouldn't solve this easier if that's what you're thinking. You're thinking, well, we can sometimes avoid duplicate code by using a loop. But it would be harder with the loop. It's simpler this way with a function, because we can pass in what's called the function arguments. Now up here we call them function parameters, and that is true. And a lot of programmers I've found in industry sometimes don't know the difference between a function parameter and a function argument. When you define a function, you declare its parameters here. This is called parameters up here in the function declaration. But here, when we call the function, here it's called an argument. Slight distinction there. Not quite trivia. It's more useful than trivia, but as I said, some people don't quite understand the difference. The textbook assumes that you know those differences, and most textbooks do, in fact. Technically, this is referred to as an argument, and these up here as parameters. Now we can comment this out. And we can keep going. Another interesting thing, well, let's say we want a function called increment. Increment. We want to say we're going to take a number, and then we're going to take another number. So we're going to take two integers here, really, I think. And we're going to say incremented number equals number plus by. So we're incrementing one number by another number, right? If we feed in 2 and we want to increment that number by 2, then really we're just adding 2 plus 2, aren't we? And then maybe we'll say print the incremented number. So let's see, if we run this, get ready to call this. So we might say 2 and 1 here. Nothing new so far. This is what we just learned above with a different subject matter. If we run this, it increments 2 by 1. 2 becomes number, and by, the word by, becomes 1. Now there's something called a keyword argument. Function keyword argument. When you start plugging in numbers into a function, these arguments here, which correspond with these parameters here, when more distance separates your code, you've got lots of other code between where you define the function and where you call it, and so it's not on your screen. You might not remember, well, what do these numbers even mean? And what is the order of the parameters up here? Especially if you had more, right? If you had, maybe you had some more complicated function, and maybe you had several other arguments up here, or parameters up here. It gets even more confusing if your input looks something like this. What do all these numbers even mean? I forget. Scroll up, and you may have to look in even in another file to find out where your function header was and what, for an explanation of everything. So with that sort of context in mind, let's get rid of all these extraneous numbers that aren't valid for our use. We can use what's called a function keyword argument. And it makes our code a lot more readable too. we can say, so now if you read this, increment 2 by 1. I mean, that actually reads like plain English, doesn't it? And that's exactly what this function does. Since we set up meaningful parameter names, we didn't call it just num1, num2. We used kind of what the numbers are really doing. Then we can put in the parameter name in and kind of merge it in with the argument. Rather than doing this, which is perfectly valid, we do this, which produces the exact same results. The only difference is readability. It lets you, the reader, the human reader, not the compiler, the computer doesn't care, but the human reader, it helps the human reader understand what this argument means without having to go read the function documentation, because a good programmer is going to put function documentation here and go over and explain what the parameters are. So this is interesting. This is also valid if you're wondering. There's no reason why you can't do this. Anytime you think there might be confusion, if you have a function that is taking in a number of variables, you can simply put a keyword argument in addition to the number or the element that's being passed. In this case, it's 2 integers. You can also pass strings into functions. You can pass doubles into functions. We're going to learn all sorts of things over the course of the semester that you can pass into functions. This just helps with human readability. And it's not required, obviously, because you can get rid of this and get rid of that, and it still works just fine. Now, if we comment this out and go on here, there's something else you need to be aware of when we get into functions. Let's say we're going to have a function that just adds a number. So add 2 and then number. And let's see. I'm sorry, let's see here. Sum equals sum plus number. Now, one thing that we can see here, well, let's just play this through and see what happens. So you can see where we go here. Let's print add 2, add 3, add 5, and then let's just go ahead and print the sum. Now, if we pass 3 into this function, it's added to our sum, which is 0, and then we pass 5, and it's added to our sum, which is 3, and it produces 8. That's kind of what we're trying to do here. I can tell you right now it's not going to work, and we're going to talk about why here in just a moment. Now, we come up here. It's complaining that we've referenced a variable before it's been declared, which ought to give us a pretty big clue here that this isn't working like we think, because this variable is outside the function and then this variable is inside the function. It's still not going to work right, but at least it'll compile and run. It produces 0, because what this is really printing down here is this variable here. It doesn't know anything about these variables in here. This is called scope. Not the mouthwash, same spelling as the mouthwash, but we're dealing with the variable scope, or the life of the variable. Everything that's declared inside a function dies inside that same function when the function ends. And next time, in the next module, we're going to look at another way to preserve data from a function. But for now, we're going to look at what is called a global variable. Because again, any calculations we do here, if we did some complex tax calculations, this is very simple. We're trying to add a number. But if we try to do other things as well, no matter what we do, it all dies when this function ends. So when this function gets to right in here, right, this point, function calls over, function ended, and now we're moving on down here. When that happens, everything that happened here is forgotten. So one thing that we can do is we can declare sum to be a global variable. This lets us access this sum rather than declaring another sum inside of here, which then dies. And it's interesting, in Python, as with most languages, you can have a variable named here and a duplicate variable name outside a function, and the program treats them as two different variables. They're not the same variable. Here, what we're saying is we're overriding that. We're saying, I want to use this variable outside of the function. This is called a global variable. And we're designating it as that. And so now when we run this, it produces what we thought we were going to make from the beginning. We feed in 3, sum is 3. If we feed in 5, 5 is added to sum, which is 3. 5 plus 3 is 8. And that's the desired output. That's what we have down here. That makes sense. But it only makes sense because we can treat sum as a global variable and not set up a local variable inside here.